Hello, welcome back to this course on structure, stereochemistry and reactivity of organic molecules and intermediates, a problem solving approach. In the last lecture, we have seen the different diastereomeric forms of perhydrophenanthrene, and then we have discussed the conformations of that these molecules, some of these molecules can adopt. These molecules means the perhydrophenanthrenes. We have seen that perhydrophenanthrenes can exist in 4 DL forms and 2 optically inactive forms, out of which one is a true meso compound and the other one is exists as a non-resolvable DL pair. Okay. Now, before we go on to the perhydroanthracenes, let me emphasize that what is the importance of this conformational analysis, because this especially the perhydrophenanthrene. Perhydrophenanthrene systems are present in various natural products which are of tremendous importance, like steroids, the ABC ring of steroids and the ABC ring of triterpenes, which is another class of molecules which contain 30 carbon atoms, and their ABC ring resembles the or this is the same as what is present in perhydrophenanthrene system. So, conformation analysis is important because conformations will ultimately dictate what type of reactivity these molecules will have, what is the energy parameter, whether it is a high energy species or a comparatively low energy species, or you can actually make a gradation of the energy scale of different perhydrophenanthrenes. Okay. So, that means different steroid skeletons, different triterpene skeleton. Okay. Now, let us discuss the perhydroanthracene, which is basically the fully reduced form of anthracene. Okay. The perhydroanthracene. Now, remember this is a system unlike the perhydrophenanthrene, which is the ABBA system. This is an AAAA system, because all the stereogenic centers, 4 stereogenic centers have are connected to similar type of atoms. Okay. So, this is one, this is another one, and this is the third one, this is the fourth one. Okay. The numbering, again here the numbering is not at all complicated. Here basically you can start from one of any, in anthracene these are the 9, 10. So, the A, if this is A ring and this is B ring, this is C ring. So, you can give number 1 here, number 2, number 3, number 4, but then jump here 5, 6, 7, 8, 9, 10, and then this is 11, this is 12, this is 13 and this is 14. Okay. So, that is the numbering system. So, what are the sp3 stereogenic centers? That is the 13, 14, sorry not 13, first 11, 12, 13 and 14. Okay. So, these are the 4, but because they are having the similar type of atoms connected. So, they are all, this is an AAAA type molecule. Okay. Because of extreme similarity, so that will reduce the number of isomers in comparison to the perhydrophenanthrenes. We will see that what is the scenario here. Okay. We will go again step by step, like what we have done with perhydrophenanthrene. So, the first here again 2 types of relative stereochemistry can occur. One is the ring junction stereochemistry, and there are 2 ring junction stereochemistry is possible, and then the relationship between these either 11 and 14 or between 12 and 13. That means, the relationship between atoms which are not the fused atoms between the 2 rings. Okay. Because 12 is the common to B and C, the ring fusion carbon between B and C, and 13 is the ring fission carbon between A and B. Okay. or you can consider 14 and 11. Okay. So, you start with giving this cis, the same type of notation cis, it could be cisoid, the ring junction could be cis or trans, and the relative stereochemistry between the non ring junction atoms will be either cisoid or the transoid. Okay. So, one could be T, the first one you can say that T and then anti and then T, that means transoid and trans. So, which here the transoid we are not using, we are using the word anti. Anti also means the transoid. Okay. So, TAT is the first one. So, what is TAT? Quickly you can draw it. So, you can put here one bold, this is we are not showing, that means the hydrogen is alpha, this is beta, and then you have anti, that means this you should not show, and this is the one. So, this is what is called TAT. Okay. Then you have systematically TST. So, TST will be what? TST will be, so again trans S, that means this is also beta, and then you do not show it because that should be your trans, that is trans. Okay. So, this is TST. So, these are the two, then you change it C, make one T as C, cis, and then you have CAT. So, what is CAT? You have, this is the ring system, then you have cis. So, if you have to have cis, that means this is beta and that is beta, that makes it cis, then is anti, so that is alpha, and then there is trans, so that has to be beta. Okay. Then the other one is C, systematically CST, that means cis, syn and trans. So, what is that? Cis, syn, trans. Okay. And then cis means this is beta, then syn, cis, syn, this, and then that one. Okay. Now, here is some one important thing to notice, that this is what is called cis, then anti and trans, and this is what is called cis, syn and trans. If you start from this direction, that will be your trans syn. Yeah, now actually what you see here, that these two are basically belonging to the no, not this one, CAT and একটু এখানে বন্ধ করবে, স্লাইড একটু বন্ধ করো. So, systematically we should proceed. We have seen TAT, we have seen TST, then it is time to change one of the T, terminal T is to C, that means cis, so that will be cis, anti and trans. So, you draw it cis, anti and trans, and then you draw the other one which is already drawn, cis, syn and trans. So, cis, syn and trans. But one thing one should be careful, that is apparently this looks like a mirror, if you put a mirror here, they seem to be mirror images of each other. So, let us see whether if it is mirror images, so their relationship will also be the similar, okay? Only the directionality should change. Okay. So, this when we start from this carbon, so cis and then anti and trans, that is okay. But if we start from this carbon and go this way in the anti-clockwise direction, so that becomes cis, syn and trans. So, this is what is represented here. So, these two are basically representing the same stereoisomer, okay, stereoisomeric system. We are not very sure whether that exists in DL form or meso, we will go into that, but we cannot have both because both are representing the same. It is the way you are starting, your starting point is. Okay. Again I repeat, the one that I have written here is what is called the CST. So, CST means basically C, S and T. But what I am saying that if you look at this molecule CAT and start your nomenclature system from this end. So, that will be cis and then syn and then the trans. Okay. So, it is basically the same cis, syn and trans. So, you just take. So, that is because it is a 4A system, that means AAAA system, that is why this is happening. It did not happen in perhydrophenanthrene. Okay. So, these are the three. Then you have some more, and that is now you have C A C, that is a possibility, change both, and that will be so that will become cis, that means both beta, then anti, do not draw it, and then cis. So, this is the one CAC, that means cis and then anti, cis, anti and then cis. Okay. This is the fourth one, and there is one more, that will be CSC, that means cis, syn and cis. So, that will be basically you have so cis means, so basically all four are having a bold hydrogen. So, that means all four are beta. Okay. So, these are the 5. Now, these are the 5, you cannot actually get any further because you have exhausted all options. Okay. First, there are 2 T's at the end. So, in the middle there will be either S or A, and then there will be 1 C at the end and 1 T at the other end, and then it will be either A or it will be S, but they are becoming same because as I said, because of the symmetry that is present in the 4A system, and then you have CSC and CSC. Okay. So, let us take some of these and try to figure out. Now, again the earlier what we have said, that the conclusion that you get from the planar, looking at the planar system, it will be whether optical activity is present or not, that will be similar even if you do the conformation analysis. Okay. So, here there is a plane of symmetry here. So, that should be optically inactive. There is a plane of symmetry, here, okay, and there is a plane of symmetry here also. Okay. So, these are the systems. So, your what will happen, your TAT, that means here it is TT, you can call it also actually it should be transoid and trans. So, that is TTT, but here we are not using the transoid word, we are using the anti word. So, that becomes TAT. So, TAT exists as a plus minus form, as you can see that there is no plane of symmetry possible here. Okay. Then you have TST, okay. TST that exists as a, that should be optically inactive because there is a plane of symmetry. Then you have this CAT, okay, CAT or CST, the same thing. Okay. So, that will be also in the plus minus form because there is no plane of symmetry. Then you have the 2 forms which will be both optically inactive, okay, OI I can say. In fact, in these systems I can tell you, wherever it is optically inactive in these systems, they are actually real meso. That means, here the flipping does not provide the mirror image. Okay. So, that means, they are actually real meso compounds, their mirror images are superimposable with each other. Okay. Let us take any one of these and do the conformation analysis or draw the correct conformation. So, let us take the TAT. Okay. So, TAT, if I want to draw this, Where is my starting point? My starting point is that I have to assign the axial equatorial nature of the hydrogens, okay? The axial equatorial nature. So, this is your TAT. Let me erase this part so that I get enough space. So, this is your TAT, and so the hydrogen here is alpha. Since it is a trans ring junction, you know that has to be diaxial. Okay. So, this is axial hydrogen, this is axial hydrogen, then there is this is 1-3 relationship. So, that will be equatorial, and that will be equatorial, because 1-3, remember, in a cyclohexane system, if you want to have 1-3 trans system, so if one is axial, the other one is equatorial, that is 1-3 trans relationship. If it is 1-3 cis relationship, then both the bonds have to be similar in nature, that means either axial or either equatorial. Here it is 1-3 trans relationship with respect in the B ring, with respect to the B ring. Okay. All the actually orientations are all with respect to the B ring, remember that. And then so that will be equatorial and equatorial. So, that again tells you that there is a problem, because trans ring junction cannot incorporate diequatorial hydrogens. So, that means the middle ring, like the previous case in perhydrophenanthrene we have seen, that will be in the, this is the middle ring, status of the middle ring, that means the B ring. And where is the E ring? The E ring will be something like this, will be something like this. Okay. Let me see whether, yeah, something like this, and the other ring will be something like that. Okay. So, this is the hydrogen, this is the hydrogen, this is the hydrogen, and this is the hydrogen. Okay. So, these are the, so that these are all trans ring junction, that is also trans ring junction. And what is the other relationship? Relationship between this and that is also anti to each other. Okay. So, this is the correct representation of this TAT molecule. Okay. So, this is the B ring in the twist boat. Okay. And what will be the additional energy over the cyclohexanes additional butane interactions that you are encountering by fusion of these rings. Okay. That energy will be basically the because you are not incorporating any for the trans ring junction, but what you are having is a twist boat form in the middle. So, the energy of a twist boat form is the additional energy over the cyclohexane chair. Okay. And this does not have any. So, this is actually existing in a plus minus mixture, because of the, you can adopt the mnemonic again and you can check by yourself. Okay. So, that is a plus minus mixture. Then we will take another one. Let us see the, suppose the TCT. What is TCT? First draw the planar form, then try to assign the relative orientation by putting dark circles or not dark circles, because the starting point is a trans ring junction. So, you make one dark and this is alpha hydrogen. Then you have a TST, you cannot call TC, TST. Okay. S means syn. Okay. So, if it is syn, if it is C, that means you are basically talking about cisoid. If it is TCT, remember about this nomenclature system. If in the middle there is C, that means it is a cisoid. In the middle, if it is T, that means transoid. Or if you see the other previous nomenclature, syn means that cisoid, or anti means the transoid. So, this is either TST you can call or TCT. Okay. Both are same. So, this is syn. So, syn means now, that means non-ring junction hydrogens are basically syn. So, you have beta here, okay, because you have to make them of similar alpha beta nature, similar. This is beta, so that has to be beta, and this is the hydrogen which is alpha. So, this is a planar form. Now, you have to put the axial equatorial nature. So, if this trans ring junction, you know that this has the hydrogen has to be axial, this hydrogen has to be axial, this hydrogen is axial, and this hydrogen is axial, because 1-3 relationship, it is either diaxial or diequatorial, but you have started with an axial here. So, that has to be axial. Okay. So, you now draw the rings. This is actually the easy one. So, you draw the rings. So, this is the situation. So, all the rings are in perfect chair conformation and then perfect trans ring junction. So, there is no question of any flipping because we have said that if any of the fusion is trans, then the flipping is stopped. So, molecule becomes rigid, and this should have a plane of symmetry going through here. Okay. You can also check this by drawing the mirror image and see that they are superimposable on each other. That is also you can do. So, these are all the hydrogens, and what will happen? You have here, suppose this you go from equatorial, axial, 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 this is axial to this B ring. Here of course, this is axial to the A ring also, but remember our notion is always with respect to the B ring. So, this is axial, 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 this is alpha, beta, beta, alpha, and the direction is, if you go this way, then the direction is clockwise. Okay. The direction is clockwise, and if you do the same thing here, see axial, 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 axial. Of course, you can take from here go to there, or you can go from here come to here, that is also okay, because all are actually axial. So, there is no difference here. However, because you have made it alpha, beta, beta, alpha, so better do it alpha, beta, beta, alpha. However, I should also point out here that this is alpha, beta, beta, alpha. So, you can go from here also to come to this via this route, you can come here. No? This is alpha, beta, beta, alpha. So, this is basically clock or anti-clock, both are possible here. Okay. So, you have to write both, that will be better, otherwise you may land into a problem if you pick out a particular one. So, again here alpha, beta, beta, alpha. So, again both possibilities are there, clockwise or anti-clockwise. So, clock or anti-clock. You have understood, I hope, that because what I am saying that if you go from here and go this way, you have alpha, beta, beta, alpha, or alternate way, if you go from this to that direction, that is also alpha, beta, beta, alpha. Okay. You should not go this way, because that makes it alpha, alpha, beta, beta, but we are not following that, we are following alpha, beta, beta, alpha. Okay. So, both these directions are possible, clock or anti-clock. So, if you now compare these two, they are basically the same, okay, because everything is matching. So, that means it is a perfect meso compound. Okay. This is a perfect meso compound. We will take let us take one more. Suppose the CCC, okay, CSC, or that is same as CCC, that means cis, cisoid, cis, the other nomenclature is cis, syn and cis. Okay. So, first draw the planar form. So, because it is cis, that means these are bold, this is bold, this is then syn or cisoid. So, all the 4 hydrogens we have to make it bold. Okay. So, now in order to do the conformation analysis, we have to draw the conformation and you have to assign the axial equatorial nature of these hydrogens. Because it is cis, so you can start with say axial equatorial, and then because it is equatorial, so syn, that means this has to be equatorial, then this has to be axial. Okay. Alternatively, you can also start, this is equatorial, this is axial, this is axial, and this is equatorial. That means two types of possibilities are there, axial, equatorial, equatorial, axial, or equatorial, axial, axial, equatorial. Okay. Both possibilities are there. So, let us draw the conformation. First draw the B ring and then appropriately put the hydrogens. Okay. Suppose this is your 11, this is 12, this is 13 and this is 14. So, 11 hydrogen is beta, okay, is beta. So, you have to make it beta, as well as if you start by putting axial, then your 11 hydrogen should be here, because that puts a hydrogen at the beta, or it could be here, that is also possible. So, you have to pick up a beta axial hydrogen. So, pick up a position according to that. So, I do it from here, that is easier. So, this is 11, this is 12, this is 13 and this is 14. So, your first ring looks like this. Okay. This is your A ring, A, this is your B and this is your C. So, A, B, now the C ring. Okay. Achha, put the hydrogens also, hydrogen here, hydrogen there. Okay. And the 13-14 ring junction, okay, that is also the 13 hydrogen is, we are taking the first one, that means axial, equatorial, then equatorial. So, hydrogen is equatorial and then axial, hydrogen is axial. Now, you complete the other ring, okay. Put some different color here, that will look better. So, the other ring will now, unfortunately, that will look like this, because you are seeing in such a direction that the projection becomes a hexagon. Okay. But the ring is in the chair form. Okay. Don't get any misconception that representing this means this is in the hexagon. That is not. This is not in the plane hexagon. That is not true. It is in the chair form. Okay. Packard conformation. Now, because there is possibility of your flipping, because the ring junctions are not trans here, both the ring junctions are cis. So, flipping is possible, okay. And that is one aspect. The other aspect is the energy consideration. The energy consideration again very similar to the earlier what we have done with perhydrophenanthrene, that here there is this methylene interaction is there. So, you have to count that. So, what I said at that time, that if you this methylene and that methylene is there, and then you have this cis configuration. So, cis decalin gives you 3 extra. So, 2 cis decalins means 6 extra. Okay. And the mirror image, let us draw the mirror image of this and try to see whether they are superimposable or not, because that will tell you whether it is a true meso or it is a non-resolvable DL pair. So, if you draw the mirror image, so draw the mirror image of the B for that B chair, and then the other ones, that means your now the 11 is here. So, that ring will look like this, that is the A ring, and this is the B ring, and your C ring will look like, as I said, will look like a plane hexagon. Okay. So, this is the mirror image. Now, the question is, are they superimposable on each other or not? Okay. So, what we will do again, we will adopt that mnemonic. So, here suppose we go from 11, 12 and then 13 and 14. So, 11 is with respect to B, this is axial, then equatorial, then axial. Okay. All are in the beta orientation, and the direction is again what? It could be clockwise, again the similar type of thing happening. because you can come from this axial, then equatorial, then axial, or you can go from here, axial, equatorial, then axial. So, both directions are possible. Okay. And here if you do the same thing, fix this, you should not change this. So, that is axial, equatorial, axial, and then all are beta, and the direction, if you go through the direction, again both are possible, either you go from this axial, take this route, or this axial and then take the route in the clockwise direction. So, both are possible, clock, anti-clockwise. Okay. So, that means both are same. So, that means that this is a true meso, as I have already said that this is in case of Perhydroanthracene, because of the AAAA system. So, all are becoming the meso is here a true meso. Okay. That means the mirror image is superimposable with the original one. Okay. And so, the question is then what is the flipping, what is the that relationship between the flipped form and the original? Basically, they are not the same. The flipped form are not the same with the flipped form is the same with the original, not the and the mirror image also same. Remember the 1,3 your transdecaline system. Okay. 1,3 transdecaline system. So, this is the scenario. Here what happens that if you draw, let me correct actually whatever I have said just a few minutes back, that if you have this as equatorial, sorry, this is beta. So, better make it this methyl here, and the other methyl to make it trans will be an axial. So, equatorial axial relationship. If you flip it, then you get this is your, so that carbon comes here. So, this will be your axial and this will be your equatorial. If you try to find out the relationship between these two, you will find that they are the same here. Okay, that what I am saying here. What happens, and if you take the mirror image, you will see the mirror image is different. Here the mirror image is actually different from the original. Here what happens, the mirror image becomes same. Now, my question is that here flipping is possible, because both are in the cis having a cis ring junction. So, flipping is definitely possible. So, if you flip it, you will not generate a new system, you will generate the original system, okay, through flipping. Okay. Like a cyclohexane chair, if you flip it, although it looks like a mirror image chair, but they are basically superimposable on each other, they are not different. Okay. So, that is an important point. Flipping is possible, but that is not changing the optical activity scenario of this molecule. Okay. I think since there is little time left, we can take another molecule and then try to draw it, okay, to make it more clear. Okay. I think we have not done the CTC. So, the question is draw the preferred conformation of CTC form of Perhydroanthracene. Okay. So, CTC form, if that be the question, then first draw the planar form like what I have said, then make it a cis CTC. Actually, this is transoid. So, you can say A also. See, the problem is either if you write only T, then it does not differentiate between trans and transoid. So, that is why I generally follow the syn anti, which does not create this confusion. Otherwise, you have to write all the way up to transoid. Okay. That is a big word to write. So, better for abbreviation purpose, this A and S are is better. Okay. So, CAC. So, CAC means cis, anti and cis. Okay. So, cis, anti and cis means this is cis, then anti, that means this has to be alpha and this has to be alpha, because in order to make it cis. So, this is the planar form. Planar form says that it is a meso compound, because there is a plane of symmetry. Let us see whether it is a true meso form or not, but in order to do that we have to draw the conformation. Okay. In order to draw the conformation, we have to first assign the axial equatorial nature of the ring junction hydrogens. Okay. So, that means this hydrogen. So, since it is cis, so you can start with say axial, then this will be equatorial, that makes it cis, and then there is since trans relationship between these two hydrogens. So, this is 1-3 relationship. 1-3 means this has to be axial, because it is they are anti to each other. Again, just if you are not that conversant, you can always make it clear that yes, if one is equatorial, then in order to make it trans, the other has to be axial, or if one is axial, the other has to be equatorial. Okay. So, equatorial axial, and this has to be equatorial, because this is syn, this is cis ring junction, sorry, cis ring junction. So, now you draw the B ring first, do not draw the A ring. The trick is that draw the B ring first. Okay. So, draw the B ring in the chair form. Okay. And then sometimes there may be some problem, as I said that there is one molecule which was basically TAT, for which the middle ring was in the skew boat or the twist boat form. But you can actually come into that conclusion anyway, if you even if you draw the B ring as the chair form, you will be having trouble later on to construct either the A ring or the C ring. So, when you have these problems, you can immediately realize that the B ring has to be in the twist boat. The other way, that always look at these ring junctions. Okay. If you see that some of these ring junction orientations is not possible, like di-equatorial hydrogens in case of a trans ring junction, then you know that the B ring has to be in the skew boat or the twist boat conformation. Okay. So, here there is as such no problem. So, you have, because there is no trans ring junction here. Okay. So, this is your B ring, and then your A ring. The A ring hydrogen, the 11 hydrogen, this is 11, 12, 13 and this is 14. The 11 hydrogen is beta. So, you have to make it beta and it is axial. Okay. So, beta axial. So, that is your starting 11. Okay. Then 11, 12 and then 13 and 14. So, 13 and 14. So, that makes it this axial equatorial, and then you have this 13. So, 13 hydrogen is alpha. So, this is your 13 hydrogen and 14 hydrogen is also alpha equatorial. So, your other ring goes like this. Sorry, my drawing was not very appropriate. Let me. So, this is the scenario. Okay. So, this is the, so all are in the perfect chair orientation, that is not a problem, and both the ring junctions are in the cis orientation. Okay. Now, the question is, it predicts, the planar form predicts that it is a meso compound. Let me see. Interesting point is that it does not have this, although the planar form tries to say that there is a plane of symmetry, but that is not possible, because this is axial, this is equatorial. So, plane of symmetry is not there. Okay. So, that is the problem with the planar form, it can give you wrong notion, no plane of symmetry. However, some symmetry is there, and that is the center of symmetry, because you see that central point whatever atoms, if this is a center of symmetry. So, there is a I present here. Okay. If that be the case, then it should be perfect meso, then it should be perfect meso. Okay. So, even if you try to suppose you you have overlooked that presence of I, or you are actually adopting the very basic premise that I will draw the mirror image and I will try to see whether they are superimposable or not. That is the ab initio approach to find out the superimposability or optical activity of a molecule. Okay. So, draw the mirror image, this is the ring B and your ring A will be, this is your C ring, okay, and your A ring will be on this side. Okay. This is your A ring. Put the hydrogens, the hydrogen here, hydrogen there, hydrogen there, hydrogen there. Okay. So, now adopt that mnemonic whatever we have learnt. So, we go from 11, 12, 13, 14, let us take that approach. So, hydrogen at 11 is, again I repeat, this relationship axial, equatorial, beta, alpha, everything with respect to the B ring. So, this is axial, equatorial, axial, equatorial. Okay. The nature is beta, beta, alpha, alpha. Okay. And then your direction is clockwise. Okay. The direction is clockwise. That. And here if you do the same thing, so here that will be you have to have axial, equatorial, then axial, equatorial. Okay. Now, axial, equatorial, I have gone from here, then come there 11, 12, 13, 14. Okay. I could have done another way, where maintaining these two same, like axial 13, 14, axial, equatorial, no sorry, this is different, that is alpha, alpha, and this is beta, beta. Okay. Now, there is a difference. You might have thought that I will go from 13, 14 and then 11, 12, but that is not same, because you are changing the alpha beta notation. So, this is axial, equatorial, keep that as beta, beta, alpha, alpha. Now, this is okay, axial, then you have to find out where is your axial is here, axial, equatorial. So, beta, beta, alpha and alpha, beta, beta, alpha, alpha. Okay. And the relationship এই আবার একটু থামাতে হবে গো, একটু থামাতে, ওটা হ্যাঁ পরে এডিট করছি আমি, তাহলে এইটুকু করে দিই, জাস্ট 2 মিনিট 5 মিনিট, মানে তাও নেই বোধহয় 2-4 মিনিট আছে, করে ফেলছি। হ্যাঁ, তুমি আমাকে বলে দিও কখন শুরু করব। Okay, so this is the situation, we are trying to compare these two, and here we decide to go from an axial. Our mnemonic says that you first fix out the axial equatorial nature. Okay, so they will do that, axial, equatorial, axial, equatorial, axial, equatorial, axial, equatorial. Then it could be beta, beta, alpha, alpha. However, here there is a little we have to be extra careful, because this axial, equatorial can also be achieved by starting from 13 hydrogen going to 14 and then 11 and 12. So, that is also axial, equatorial. Okay, that we have to remember. So, so when we write this, because there are two possible ways of achieving this axial, equatorial. So, if you fix this as your reference point, starting point, and suppose I now see our alpha beta nature, basically we are looking from the top, okay, and that gives us that this is beta, these two are beta, these two are alpha. Suppose I look from the bottom, change the reference plane, that means I look from the bottom, then what will be earlier alpha, that will be beta, what will be earlier beta, that will be alpha, and then alpha becomes beta. Okay. Beta becomes alpha, alpha becomes beta, but axial, equatorial remain the same. Okay. So, if I look from the bottom, change the reference plane, then what will happen, that this will be again axial equatorial, but I can get another version of this. Then this will be beta, that will be alpha, this will be alpha, that will be alpha, because I am looking from the bottom, from below, okay, and changing my reference. Okay. So, the below bonds are now beta and the above bonds are now alpha. Okay. So, what will be the direction now? Apparently, whatever direction you see from the top, it will be just the opposite when you look from the bottom. So, now I am starting from 13, 14, 11, 12. So, this looks like that this is going in a clockwise direction, but actually that will be anti. Okay. So, you have to do both here. So, similarly, you do both for this molecule. So, what will happen? You fix this axial equatorial. However, as I said, there are two possibilities, that this is this could be your beta. Now, my reference plane is from the top. So, I am seeing from the top. So, beta and then alpha and the direction is anti. And if you look from the if you change the reference plane, that I look from the bottom, and then I can start from this one, axial equatorial and then axial equatorial, if I do that, and then you see, then this will be beta, alpha, and apparently the direction is anti, but that becomes clockwise, because I am seeing from the bottom. So, whatever way you do, you see that there is similarity here. This one becomes similar to that one, axial equatorial, beta, alpha, this is clockwise, or you can compare these two also, that becomes identical with that one. So, basically these two are identical with each other. So, that actually this is a special molecule where you have to be extra careful to adapt this mnemonic, otherwise you may land into problem. If you can see the I this inversion point, then it is well and good. Otherwise, adapting this you have to be extra careful, because as I said, this axial equatorial can be achieved in two ways here, because of that symmetry, that it is a 4A system, A system. So, that created all the trouble, and you have to be extra careful in comparing these two. So, they become similar, they are same actually. So, that means it is a true meso. However, again just repeat that same, that there is no plane of symmetry. What is present is a center of symmetry. Okay. What is present is a center of symmetry, and overall conclusion remains the same, okay, that it is a meso compound, but your justification for having this molecule in the meso form is completely wrong if you compare the planar form. Okay. I think that takes care of the tricyclic system. So, we have gone through the perhydrophenanthrene in this session of the lecture. Perhydroanthracene, because it belongs to a 4A system. So, it has actually less number of isomers. So, ultimately what happened, that it has 2 DL pairs, it exists as 2 DL pairs and 3 mesoforms. There are several important issues that are, while you consider the number of stereoisomers in perhydroanthracene and also its optical activity, that one important thing, that because of the symmetry present here. So, two things became similar, like this cis, syn and trans, and cis, anti and trans, they are basically representing the same diastereomers. Okay. So, that truncates one number. So, here 2 DL pairs and then 3 mesoforms. Earlier was for perhydrophenanthrene 4 DL pairs and 2 mesoforms. Okay. So, number of mesoforms got increased, the number of isomers got decreased. That will always happen when you have increase in the number of mesoforms. Okay. And we know how to draw the different conformations of these various stereoisomers. The trick is that write the B form and also assign the axial equatorial orientation in the planar form and then convert it into the Packard form, that means the non-planar form, the actual conformation. Okay. So, I think that takes care of this perhydrophenanthrene and perhydroanthracene. Okay. So, thank you very much. Next day we will do it will be a problem solving session. So, we will have different problems and we will solve that. So far we have gone through the cause of stereoisomerism, then the point group, the symmetry point groups, the symmetry number, then the order of symmetry, and then we have done the absolute configuration of chiral axial chirality containing molecules or the planar chirality containing molecules, and then and the helical chirality. Then we have done the bicyclic system, bicyclic cyclohexane system and the tricyclic cyclohexane system. So, we will do the next class, we will do the problem solving. Okay. Thank you very much.